myself. My name is Rob Yamry. I'm the senior systems engineer for Extreme Networks that covers mostly the Wisconsin territory, but I do branch out into neighboring regions to help out other SCs and wherever some customers or partners may need a little bit of assistance. But today for this webinar that Daryl and Advanced Wireless is putting on, we're going to have two topics that we're going to cover here, which is some newer technology that Extreme Networks has in our portfolio. The first one is the new 802.11ax wireless standard. Even though it's not ratified yet, we do have our access points released out here. We can talk about this a little bit, and then we'll segue into Extreme AI, where we can build off of some more metrics and some software as a cloud solution to automate your wireless RF management. So let's just kick it off with what is 802.11ax. I'm sure a lot of you have heard this term around. Just recently, there has been a new naming standard put onto all the different standards that we have. So we have Wi-Fi 6, which is 802.11ax. Wi-Fi 5 is AC Wave 1 and Wave 2. There's really no differentiation between the two waves for 802.11ac. And then 802.11n is Wi-Fi 4, and then it just keeps going back and back up until you get to BNG networks. But as we're going through the wireless evolution, Wi-Fi 4 was built off of high throughput, and that's 802.11n. And then going up a little bit further, the AC Wave 1 and 2, Wi-Fi 5, that was built off of very high throughput. And now we're at the Wi-Fi 6, 802.11ax. And for this one, we focus on efficiency. It's known as the HE-PHY, the high efficiency PHY. So there's a lot more efficiencies built into this. There's a lot of features in here to help some of the problems that we have in Wi-Fi 5 as far as density, range, coverage, battery life, and just overall speeds for it. And you can see some of those features over on the right-hand side of the slide there. For the focus of this presentation, though, we're going to focus in on the high efficiency portion of it. And Wi-Fi 6 is all about wringing out more out of your Wi-Fi spectrum. We want to be able to support more clients. We want to use the spectrum that we have on here, and we want to almost create like a Wi-Fi switch type of environment, even though it's still a one send, one receive for wireless. That's just how RF works in general. We're getting a little bit closer to where we can reap the benefits of, basically a Wi-Fi RF switch. Think of back in the days when we had hubs on the network and we went to switches. It was a drastic improvement, and we're nearing and getting closer on that. So how are we going to do this? Right now with Wi-Fi 5, everything that we know of right now operates on 20, 40, 80, or 160 megahertz channels. And as I mentioned before, it's one send, one receive. So only one client can send a packet at a time. And, there's some little bit of adjustments that we can have to that to make that a little bit more efficient. But everything that people typically think for wireless is backwards of how to improve it. You typically think more power, more APs, bigger channels, when in reality, we want smaller channels, AP cell sizes shrunk down so that we can limit what the clients are using on there, so we can put a little portion to it to what they can use, so we can have more clients and more support on the RF. So one of the ways that 802.11ax does it is that instead of that 20, 40, 80, 160 megahertz channels, we take it the other way, where we can go down to 8, 4, and 2 megahertz channels. So we can support much more high dense environments. A little graphical color here. We got a good thing depiction with the traffic jam here. We got the truck on the lower side. Another client or a vehicle is trying to get around. The truck is blocking it. That's kind of how it operates today. And then we have multiple lanes over on the right hand where we can basically splice up these channels into smaller segments so we can support more clients on it. This is another little depiction on it here where you can see over on the left we have 80 megahertz channels, or 40 or 20, and that's kind of how it is for RF. But with Wi-Fi 6, you can see how much more spectrum we can use based off of color coding the packet for multiple transmissions and allowing the client to send and receive together in a text op for a transmission opportunity. All right, and this isn't a static type of thing. It's not like one client chooses 2 or 4 megahertz and it stays at that, and that's how it is while it's on the network. This is dynamically changing per tick stop. So each transmission a client sends, it determines what the spectrum it's going to use for that. And that's where you see the real difference between OFDM, which is more along the lines of Wi-Fi 5, that's orthogonal frequency division multiplexing, a little tongue twister there. And then OFDMA is what Wi-Fi 6 uses, and that's orthogonal frequency divisional multiple access. OFDMA is basically a multi-user version of OFDM. So as we see the different colors on here, where people are, where clients are transmitting, you can see the resource units changing with and dynamically going on the fly. So think of it like this. Think of when you're looking at the Windows client speed throughput, and you typically see X amount of megabits per second throughput, 430 or 450 or 300, and you typically stay that unless if you move a certain distance away. On Wi-Fi 6, when we have clients out here and we start seeing this OFDMA portion of it, you're going to see that number jump around so much that it's going to be almost hard to read. It's going to be a blur. It's going to be jumping around all over the place because it's every transmission that client has, it determines what spectrum it's going to use, and that'll dictate back what the MCS rate that we're going to use for that client to be the most efficient on the network. Of course, with any new Wi-Fi standard, we have to have the APs themselves supporting it, but we also have to have the clients that support it too. Now, the Wi-Fi 6 standard is going to be ratified soon. It's not there yet. We're going to see the final plug fest, what we call it in the industry, where all the major vendors get together and make sure we have all the interoperability okay and set with that. But the way that we as Extreme Networks release our access points, it seems, if you look at the graph here, that we were a little bit late to the game, but in reality, we were just at the right time. Some of those other competitors early on to the left of the screen there, some of their APs will not be compatible with the Wi-Fi 6 standard at all, and that's hardware based. So some people purchased those and they wanted to become Wi-Fi 6 compliant and become part of the standard once it is ratified. Those ones will be basically a hardware rip and replace. So we're almost referring to those as AC Wave 3 because they'll never become fully Wi-Fi 6 compliant. When ours came out, we have the right hardware in there to be able to support the new features that will come out when the standard is fully ratified, and we'll be able to update our access points with a simple software update so that we can become fully certified and compliant. There are a couple clients out there already. The Samsung Galaxy S10, I believe, was the first AX client to be out there. And there's some other ones coming out. Intel released a chipset for now too. But in order to reap the full benefits of the AX standard, we have to have the clients out there and adopted. So we can start to put the hardware in there so that when we see the clients come in there, we can automatically support and utilize the AX benefits, but we won't see that widely used until maybe mid next year or so. All right, so the two access points that we have are both 4x4 access points. We have the model 510, which comes in an internal and external antenna version. This AP in particular has 2 Ethernet ports on it, which both can be used to power up the AP. So we call this redundant PoE failover. It also supports 1, 2.5, and 5 gig multi-rate on the wire. It has an integrated BLE radio, which is great for locationing services or however you want to use that radio for IoT devices. But one thing that really sets us apart from our other access points is that this one is finally a dual 5 gig capable access point. So we can operate in 2.4 and 5, which is the traditional one. If we have some customers that are a little more security conscious, we can take that 2.4 software configurable radio and turn it into a sensor. So we can start using some of our peripheral products like air defense or something else like that to see what's going out in the air and mitigate some of those threats. And then if we're looking in a super high dense environment, a lot of higher ed schools, stadiums, that's where we can use dual 5 gig. We can set that 2.4 gigahertz software configurable radio into a 5 gigahertz radio. So we can have two 5 gig radios on that one AP. The other one that we have is the 505. It's very similar to the 510. Form factor is basically the same. It still has two Ethernet ports on it, but it cannot be powered off of the second Ethernet port. This one only goes up to 2.5 gigs multi-rate on the wire. So those to support the speeds that you need for the access for the wireless clients. And this is also only an internal radio model as well. So part of the access points that we have Wing 7, and that's what is the operating system that runs our access points. Inside there, we have something called Smart RF, and that's a technology that we use to automatically set power and channel. Make some little tweaks on there. If there's large interference in the 2.4 radio, we can shut that off to help mitigate that interference. But there's also some portions of Smart RF where people or network administrators need to know somewhat what's going on with their network. And what we're trying to do is we're trying to decouple that. We're trying to take that and put it onto an AI platform so that you can deploy your access points wherever they are. Key performance indicators, KPIs we call them, will be watched upon, and we can determine what actions to take on your network automatically so that it's basically hands off. And over time, the software will begin to understand your network and make changes automatically. And this is where we segue into Extreme AI. So Extreme AI is out now. It's shipping. It's available on a portion of our access points, but it's really the intelligent Wi-Fi operation that we're trying to bring into our access points to mitigate a lot of potential issues. And this is more than just power and channel. This is looking at link quality, frame packet errors that are going on there, frame errors that are happening on there. Maybe some clients are sticking to an access point that they are in another area where there's a better one for them. And even though they haven't met those roaming thresholds, the Extreme AI service can take that, see that difference, and be like, all right, this client should be over on this access point. Let's pop them over there. And then so there's all these other proactive mitigations that are happening on the network. The way it works, it's a closed loop system. Now look at the orange portion here where it starts with automatic detection of issues. It starts there. It starts to look at your network. A lot of the access points are sending a lot of information back to the service. It's doing a lot of calculations, some algorithms on there. It's running through a lot of processes, and it detects those issues. It runs to the next one. It just goes round and round in circles. So it's just constantly going around there, finding new issues, making some diagnosis, correcting it, updating the machine learning modules, and then putting policies and algorithms into place for it. And this is constantly happening throughout your network 24/7. All right, so let's get into a couple of these screenshots for here. Extreme AI is very scalable. It's not limited to X amount of access points. When you roll this out, whether it's a local location, a remote location, or whatever you may have on your network, you can enable a service on here to start to take control of your network. You can have these changes be automatic on here, or you can just kind of sit back and see what it finds and then approve them as they go. But it's like having a bunch of network engineers' hands on the Wi-Fi all the time. When we know that people are becoming overwhelmed with the RF, especially in certain areas where they may not have the full familiarity of some RF, because RF can be tricky. And with how networks are growing, before we had the coverage model where it just place up access points for basic coverage, but now everybody's going over to density. And once we get into those type of situations, it becomes a lot more tricky to manage power, manage clients, make sure everything's roaming right, make automatic corrections, minor adjustments and tweaks here and there. You could have multiple people with a full-time job just looking at the RF and the Wi-Fi and making these little corrections. But that's where we're going with Extreme AI. We want to enable this service on the network so that it can take that workload off of you and you can get your ROI back on there. You can start to stop working on day-to-day fires, on these little, things here and there that you want to do, and start focusing on bigger projects. As we spoke before, it's very proactive, and there's some nice features in here where if the AI service starts to see an issue, like at its one site and two sites, where it's kind of like stringing along, it has the knowledge and the capacity to determine at other sites, these ones may see the same issue that the other sites have had, so let's proactively change there before the end user even sees the issue. So we can have issues that come up and are mitigated, be propagated throughout the network even before an end user sees it. And it's really about determining root cause and mitigating it. So the thing is with extreme AI, or just in RF in general, when clients think of performance, it's very subjective. Speed to one person could be fast. It could be the exact same to another person, but they're saying it's slow. So we have to have a way to objectively measure these KPIs throughout the network, so that we can make these changes on here. If we have subjective information coming in, we can't really quantify it. We can't make objective decisions off of it. So that's why we're looking at all these KPIs throughout your network, so we can throw something back at this, like 66 hours in this case of manual troubleshooting eliminated. That's huge. That's over a week and a half of somebody's time of sitting there troubleshooting wireless issues. So looking at all these KPIs, these indications, all these other little stats that are on the network that most people would just look and just breeze over. They kind of don't even, pay attention to a lot of this stuff. The AI service takes this all into account and categorizes it, quantifies it, and then makes changes based off what would be the best way to gain better performance and end user experience on the network. And that's what it's really about, is getting the end user experience consistently across the network. Getting all these KPIs in here, looking at all these statistics, making all these mitigations, optimizes, and changes here, and doing it all at machine speed. It's one thing to have RF engineers taking their time and doing troubleshooting for this, and then going through and making changes for it. But think of how many times that we go in, find an issue, have to click around, do a couple things. We're looking at a few minutes. I mean, what if you could do this in milliseconds? That's a huge benefit to that. And just going over into the support portion of it, we're looking at lower support costs, lower personnel time to be able to support the wireless. If you can offload this, you can start working on deploying your network, larger projects, moving your network forward into the new age, and start using some of these other services like Extreme AI to optimize your network.